Okay, so let's start the topic now. We will going to design 3-bit up counter synchronous circuit using D flip-flop. So for designing this circuit, we will follow these 4 steps. First one is the drawing of a state diagram. In the second step, we will draw the state table. Along with that, we will also write down the excitation table of D flip-flop, as we are using D flip-flop here. In the third step, you have to draw the K map for finding the expressions for input of D flip-flop, and then we will draw the circuit diagram. So first you see what is the meaning of up counter. In the normal words, I can say that it is counting upward direction 0, 1, 2, 3, 4, 5, 6, 7. And after that it becomes 0 because we are using only 3 bits. And with the 3 bit, the maximum number will be 7. Now, here you see in the state diagram. A state diagram is nothing, just the representation of these numbers in the binary form. As we are using 3 bit for the representation, then first number I am writing as 0, 0, 0 because for 0 we are using 3 bits. Now here the next number is 1, so it's 0, 0, 1. Next number is 2, so 0, 1, 0. Next number is 0, 1, 1. Next number is 1, 0, 0, 1, 0, 1. So it's 1, 2, 3, 4, 5, then 6, then 7, and then 0. Whatever we have written in the decimal number form, the same we have represented in the binary form, and this is called as the state diagram. Now we will use this state diagram for writing the state table. For the state table, we have 2 parameters. So first, for the state table, we will write down the present state. Then we will write down the next state. So as we are using the 3 bits for the representation, here we will write down as QC, QB, and QA. Right? These represents the 3 bits of the present state. As we are using 3 bits, total possible combination will be 8. I am writing all 8 possible combinations here. So with the 3 input, we can represent different 8 numbers. So I have represented 8 different numbers. Now you see, if you are in the state 0, 0, 0, what will be the next state? As this is the up counter, after 0, 0, 0, next state will be 0, 0, 1. Right? So this is 0, 0, 1. And as the next state, I am representing as QC plus 1, QB plus 1, and QA plus 1. To represent these are the next state for the states QC, QB, and QA. Now, the simple meaning, if you are in state 0, 0, 1, that means actually in the decimal form it's 1, so the next state will be 2, and 2 will be represented as 0, 1, 0. Similarly, if you are in state 0, 1, 1, actual meaning is 2, so it's the next state will be 0, 1, 1, that means 3. From 3 it will be 4, 1, 0, 0. From 4 it will be 5. The same you can also check from the state diagram. That means if you are in state 4, what will be the next state? If you are in state 4, then the next state will be 5. Right? Same we are doing it here also. So after 5, it will be 6, 1, 1, 0. After 6, it will be 7, 1, 1, 0, 1, 1, 1. And from 1, 1, 1, what will be the next state? After 1, 1, 1, it will be 0, 0. So you can write down as 0, 0, 0. Now this table is completed. After that, we have to decide which flip-flop you are going to use to design the circuit. As in this circuit, we are going to use the D flip-flop, so we require the excitation table of D flip-flop. It says that the Qn plus 1, and this is the value of D. So 0, 0, 1, 1, 0, 1, 0, 1. This is the excitation table. It says that whatever will be the value of next state, that is Qn plus 1, it is similar to that of D. So if you want to find out the value of DC, DB, DA, if you want to find out the value of DC, DB, and DA, it is similar to that of QC plus 1, QB plus 1, and QA. That means if you want to find out the value of QC, you just write down the same value of QC plus 1. So I'm just noting the same thing here because in the excitation table we have seen the value of D is equals to Q of n plus 1. So I'm just representing the same thing here, whatever is written in QC plus 1. Here for DB also it's 0, 1, 1, 0, 0, 1, 1, 0. Similarly, it's 1, 0, 1, 0, 1, 0, 1, 0. Now it's completed. Now we have to go to the third step. In the third step, you have to draw the K-map for DC, DB, and DA. So now here we will go to the K-map representation for DC. As we are having 3-bit as an input, we have to make the 3 variable K-maps like this 0, 1, 0, 0, 0, 1, 1, 1, 1, 0 because it's following the gray code. Now we have to check for which combination the value of DC is 1. So now here you see DC is 1 4 times, 1 for 0 1 1, next 1 0 0, right? This is 1, so 0 1 1. This is 1 here for 1 0 0. This is 1 here for 1 0 1. Again, it's 1 for 1 1 0. So the same thing here you have to fill. This is 0 1 1. This is 1 0 0. This is 1 0 1, and this is 1 1 0. So now I filled it. Now we have to make the group. So if you see, I can make one group like this. I can make one group like this, but for this combination, we don't have any group. So you have to make it individually. Now you you write down the expression. Here it was QC, this is QB, QA. Now this is what for this combination, for this individual combination, you can write down as QC bar, QB, QA. Similarly, for this combination, it is QC and QA bar. Plus, for this combination, it is QC, QB bar, right? So this is the expression that we got. QC, QA bar, QC, QB bar, and this expression, this is for DC. Now we have to see what will be the expression for DB. For DB, again, we have to make a 3 variable K map like this. This is 0, 1, this side I'm taking QC, this side I'm taking QB, QA. This is 0, 0, 0, 1, 1, 1, 1, 0. Now we have to fill the value wherever your value of DB is equals to 1 for different combinations. So here it's 1 for 0, 0, 1. It's 1 for 0, 1, 0. And again it's 1 for 1, 0, 1. And again 1 for 1, 1, 0. So here I am writing it here and fill the K map. So this is 1, 1 0, 0, 1, 0, 1, 0. Then 1 0 1, and this is 1 1 1. Now we can make a 2 circles and 2 groups here, and this is QB bar QA, and this is QB QA bar. Now we will draw the K map for DA. It's also a 3 variable K map like this. Here I'm taking 0 1, this is QC, this is QB QA, this is 0 0 0 1 1 1 1 0 because it's also following the gray code. And now we have to fill this K map wherever your DA is 1. So now DA is 1 for this combination. It's 0 0 0, then 0 1 0, then this is 1 0 0, and this is 1 1 0. Now you see in the K map how we can fill it. So this is 1, this is 1, this is 1, and this is 1. Now we can make a quad here. That means some combination of 4 ones, and the expression of DA here is cancelled. Here 0 0 only left, that is QA bar. So now we have all the expressions. I am writing it once again, and then we will make the circuit diagram. So here by using the K map, we have derived the expression of QC. We have derived the expression of DC, that is equals to QC QB bar. The expression of DC is equals to QC QB bar plus QC QA bar plus QC bar QB QA. Similarly, we have derived the expression of dB is equals to QB bar QA plus QB QA bar. Similarly, the expression of dA was QA bar. Now we have all the expressions and we have to draw the circuit. So now here, as we are using 3D flip-flops, I'm writing it like this. This is first flip-flop, second flip-flop, and this is the third flip-flop. Always remember the most significant bit will be the last flip-flop. So here D and this is B. This is D flip-flop and here I'm writing A. So the value of DA is QA bar. Directly I can write down like this. In the DB we require two AND gates like this because here we have QB bar and this is QB bar, this is QA. Similarly here we have QB, QB, QB and QA bar. Both you have to give it to the OR gate and that value will be working as a DB. Similarly for DC we require three AND gates like this, right? And the values are QC, QB, this is QC, this is QB, this is QC, QA, and that is Q bar, QA bar. This is QB bar. This is three inputs. So this is QC bar, this is QB, and this is QA. All you give it to the OR gate like this, and whatever will be the output you provide as a DC. As this is a synchronous circuit, we have to provide the same clock to all the flip-flops. You also draw QA and QB and QC. Here you can also draw the inverted output. This is the clock. QA bar, this is QB bar, and this is QC bar. So this is the circuit diagram for 3-bit synchronous up counter using D flip-flop. Thanks for watching.